Hello and welcome to this lesson. Today we're going to be looking at set notation and interval notation. So this little Venn diagram at the top here is just showing the different types of numbers. So we could have the real numbers, which is R. We could have rational numbers, which we denote with Q. And we've got Z, which is our integers, and N, which is our natural numbers. So what this is just a refresher of is the different types of numbers you'll come across. Real numbers include everything from negative infinity to positive infinity, and then rational numbers are all of those real numbers that can be written as a fraction. It's a nice way of thinking about it. So non or irrational numbers, you'd have things like surds, which wouldn't fall into that queue, but every single rational number exists between negative infinity and infinity. So we can see that all of that green circle there in the Venn diagram Q is inside the R. Then going a level further, we've got Z here, which is our integers. So they're all of our positive and negative counting whole numbers. So -3, -2, -1, all the way through. Then the innermost circle N is our natural numbers. So these are the ones we can physically count something of, the amount of objects. So 1, 2, 3, 4, all of our positive whole numbers. Now, if we want to show that something is inside another group, so all of the natural numbers you can see here, N, exist within the integers. We can say that N is a subset of Z. Or we could say Q is a subset of R, which basically just means that every single rational number in here, any possible Q, must also be a real number. So it fits inside R. Now there's a certain symbol that you might not have used it before. It looks like this. So if we wanted to say N is a subset of Z, we can just use this symbol here. Okay, it looks like a C with an underline. And then same thing for Q is a subset of R. So that just shows that every single element in Q is also in R. There's a couple other notations that you might have come across in the past. So let's draw another little Venn diagram here. I'm just going to use A and B. If I have two groups A and B, two sets here, then the middle part, the intersection here, I can denote with this symbol, which means intersection. And as you can see from the shaded in part, it's all of the elements that are in both A and B. So for example, I could say A is all the numbers from 1 to 10, and B is all the even numbers under 20. So the numbers 2, 4, 6, 8, and 10 would fit in the middle, and then out here I'd have 12, 14, 16, 18, 20. So the numbers that are in both under 10 and even would go in the middle. When we're reading it, intersection, that means it's in A and B. Alright, so if you see that symbol there, I like to think of it, it looks a bit like an N. Alright, and that's got an N in the end, so that's how I remember it. If it was in A or B, so I was interested in any number, but it's in either of those, then I use the upside down version of that. It looks like a U, and we read that as the union. So that's the A union B, means it's in A or B. So the other types you might come across, if we've got subsets, we've got union, we've got intersection, you might be asked to say that is not in part of it. So it doesn't belong in there. So we can say that something is not an element of. So we use this symbol. So looks like that. We read that as belongs to or is an element of. And we can put a line through is not an element of. Okay, and if we had that, read it as belongs to or is an element of. So for example, let's say A is the numbers 1 to 10, then I would say that 12 is not an element of A. Okay, doesn't belong in there. So that's just a refresher of some of the symbols you might come across. Now, we're going to use these to denote intervals of numbers. So when we're graphing functions and stuff later on, we're going to be looking at domain and range, and where graphs and functions exist, we're going to be looking at a set of x or y values. So we need to use some of these symbols to help explain it. So let's look at a couple of practice questions. We've been asked to show the following intervals on a number line. So where we see this square bracket, that means that it does exist. So -3 is an element of that interval there. So on a number line, if I'm showing from -3, -2, -1, all the way up to 4, to show that it's including the numbers, so we're talking about from -3 up to 4. If it's got a square bracket, we use a coloured in circle to show it does exist, and we can use a hollow circle at -4 to show, hey, oh sorry, +4, we've got a curly bracket, which means it doesn't exist there. Another way we could write that, let's say we're talking about these are x values. So let's say I had x belongs to, sorry, is an element of -3 to 4. Then I could draw it as a number line from here. If this is my values for x, I could also say that x is greater than or equal to -3, and it's less than 4. So notice if I've got a equals to sign underneath my greater than or less than, I have a square bracket and I have a coloured in circle. Okay. Whereas if I've got no greater than or equals to, it's just a less than sign here, then I have a curved bracket and I have an open circle. Okay. Let's look at that last one, part C. I say -2. I could do on my number line -1, 0, 1, 2. So if I'm looking at those two, then this is just going to be closed in circle, because I've got a square bracket, closed in circle, square bracket, and it's just those two. So x could be -1.8, for example, anything that's in between -1 and -2. If we've got an infinity in there, you're always going to have a curved bracket, because infinity is not a point, can't exist there. So for that one, when you've got your number line, 3, 4, 5, etc., it's everything that's greater than -infinity and less than or equal to 3, so coloured in circle, and then we just draw an arrow to show, hey, it's absolutely everything that's below that. Okay, so to recap, square bracket, whole circle means equal to. Curved bracket, hollow circle does not equal to. Now we're introducing some union and intersection symbols. So let's look at this question here. We've got illustrate -3 to 2 inclusive, union from 4 inclusive to 8 inclusive. I want to show that on a number line. So remember, if it's union, that means or. So when I draw my number line, I can have -3, -2, -1, 0, 1, 2, 3, 4, 5, 6, 7, 8. Right, I could go put all these in. I was just being lazy. So for that first part, remember it's or. So I'm going to have two separate lines. I've got here -3, and they're both square brackets, so -3 and +2. Both closed in circles, and I connect it. And then I've also got, I'll change color here, 4 to 8. So again, both are square brackets, so both are colored in circles. So I can have any of the values in between -3 and 2, or I could also have between 4 and 8. So that's where these exist. Looking at part B, I've got from -infinity up to 2 inclusive. So 2, 1, 0, etc. So I've got this colored in circle going down, and then from 4, so that'd be 3, 4, 5, etc. I would have colored in circle and all the values going up. If I have an intersection, it's saying it has to be in both. So it has to be between -infinity and -3, and between -6 and +infinity. So I was to draw that number line, just like I did in the previous question. So -3, -4, -5, -6, -7, etc. Okay. Then when I draw the first part, -infinity to -3, now it's a hollow circle. So that's all that. And then the other one is from -6 all the way up. Now, I only want that's in both. So any values here, so at -7, for example, it's not in the purple line. So I can't actually have this part. And same thing at -2 or anything above -3 doesn't exist. So I'm only looking for where the two lines overlap. So my final answer should just be, oops, I didn't mean to rub off my number line there. My final answer should just be the values between -3 and -6. Like that. So it looks a bit like a dumbbell. And the last one, -infinity all up to 1. So where's my 0? 1, 2, 3, 4, 5, -1, -2, etc. So I'm going from -infinity up to -1. And then I'm going from 4 to infinity. And you go, uh-oh, doesn't exist. So therefore, I have nothing to show here. All right, it's an empty set. And if I wanted to show an empty set, I can use this symbol here. Okay, so equals an empty set. Doesn't exist. So there's no possible overlap between those lines. Okay, now, why are we doing all this? When we get towards the end of this chapter, we're going to be looking at sketching graphs and equations and giving restrictions on the domain. So let's say I want to sketch some function. Let's say y equals x squared, but I'm only sketching it for x is between, let's say, -2 and +3. So you might be given an equation like that, or you might be given where x belongs to -2 to 3. Two different ways of writing the same thing. So all that means is we're going to be working towards sketching a graph. X squared we know is a positive parabola. We know what it looks like here, but it's only going as far as -2. So at -2 I'm going to have +4 for my y value, and it's going to be a hollow circle because I've got a round bracket, or it's not equal to. Then at +3 it's going to be at 9. Again, it's going to be a hollow circle. So my final equation, or my final graph, is just that part of the parabola. Okay, that's what we're looking at for chapter 5. So for 5A, we're just trying to familiarize ourselves with the notation and how to write things. So have a go at the questions, and if you want to look ahead to some of the sketching graphs to make a little bit more context, you can do that as well. Don't forget to use your textbook and your chapter summaries to help you build out your notes and help you with some of those worked examples. Okay, all the best.